Okay, so these are some quick notes on interval notation for domain and range, and the content objective is going to be to write the domain and range of a function in interval notation, and our language objective is going to be to define domain, range, and interval, as well as things like less than, equal to, all real numbers, those sorts of things, but terms associated with domain, range, and intervals. So we're going to just do one example together and then a couple quick checks. But our first example asks us to write the domain and range of the function below. So I'm going to draw our axes. We have x-axis, y-axis. We'll say 1, 2, this will be 3. 1, 2, 3. This will be -1. Okay, so I'm going to draw our graph. So we have a quadratic opening downwards, and the first thing we're going to do, step 1, is determine if there are any restrictions. Or boundaries on the domain, which is our x values. So are there any restrictions on our domain? And since this implies it is going infinitely out, so it might be a little hard to tell, but these are going infinitely out. There appears to be no restrictions on our domain based on the graph. Also, since we know it's a quadratic, we know there won't be any restrictions unless otherwise stated. But if you're looking at a graph like this, when you're looking for restrictions on your x values, there are a couple key things you can check for, which are starting or stopping points, or asymptotes. And again, we'll talk about asymptotes in a later unit. Don't worry about them for now, but asymptotes would create a restriction or boundary on your domain, so we do have to look out for them. But since there are no restrictions on our domain here, we're going to write the domain either as all real numbers, or if there were restrictions, we would write it as an inequality with x. So in this situation, our domain is going to be all real numbers, and I just abbreviated domain as D, but all you're going to do is write all real numbers since there are no restrictions or boundaries on the domain. Our next step is going to be to do the same thing for the range. Determine if there are any restrictions. Or boundaries on the range. So again, for this, you can look for a few different things, including maximums or minimums, or starting or stopping points. Sorry, backing up. Starting or stopping points, asymptotes, so the same thing as your x's, or maximums or minimums. And in this situation, if we look here, we have a maximum at y equals 3. So we know that it's going to go down after that, so it's going to be everything below 3. So we're going to write a range. And again, this will either be all real numbers or an inequality with y. So since it's not all real numbers, we're going to write it as an inequality with y. So I have my range is y, and since it includes that and goes below, it's going to be less than or equal to 3. So y is less than or equal to 3. I'll add an or in for these. So that is our range. Let's do a couple quick checks to make sure we're all on the same page. So again, I want you to write the domain and range for the following functions. So I'm going to give you 2 here. X-axis, y-axis, 1, 2, 3, 1, 2, 3. Okay, this is -1, 3. All right, and we're going to do that. So that's one of our functions. Go ahead and write the domain and range, and then the other one, another quick check we're going to do, I'll draw right here. Okay, so this one. Okay, so there are 2 functions. Go ahead and write the domain and range for each of those. I'm going to go over them, so if you are still working on it, pause this video. So for this one, we're going to start with our domain. And again, we're looking for asymptotes or starting or stopping points, and we notice we have a starting point right there at -3. And so our x values aren't going to exist before -3, but it appears they will exist everywhere after, given the arrow. So we know x gets greater than 3 after that initial, or -3 after that initial point. So x is going to be greater than, and since the circle is filled in, or equal to -3, and that's our domain. Our range, similarly, we have a starting or stopping point. So our starting point is here at y is equal to 0, or on our x-axis. So we know that y is going to go above that, so it's going to be greater than, and since it's a filled in circle, it will also be equal to 0. And that's our range. The last one, we have an absolute value function. We have a minimum down there. Our domain, there appears to be no restrictions since it goes forever in both directions in the x-axis. Sorry, I didn't label out my axes. Whoops. So our domain will be all real numbers. So our domain is all real numbers since there's no boundaries or restrictions on the x values. And our range is going to start here and go up. So it won't hit any y values below -1. It's only going to hit the y values above -1. So y is going to be greater than, and since it's filled in again, or equal to, -1. Y is greater than or equal to -1, and that is our answer. Sorry, if you have trouble reading that, that's the -1, my bad. So make sure you write down any questions, comments, concerns on this, and I can answer them in class.